Today we're covering differential calculus for the FE exam, focusing specifically on critical points, L'Hopital's rule, and partial derivatives. These topics are found in the mathematics section of your NCEES FE reference handbook. On the exam, you will see these concepts in standalone problems asking you to find a maximum or minimum, evaluate a limit, or compute a partial derivative. First, let's talk about critical points. A critical point of a function f of x occurs where the first derivative, f prime of x, is either equal to 0 or is undefined. The exam almost always tests the f prime of x equals 0 case, which identifies the horizontal tangent lines at local maximums and minimums. For example, if you're given the function f of x equals x cubed minus 6x squared plus 9x plus 1, the first step is to find the derivative, which is 3x squared minus 12x plus 9. Set this to 0 and solve for x. Factoring out a 3 gives x squared minus 4x plus 3 equals 0, which solves to x equals 1 and x equals 3. These are your critical points. To classify these points, we use the second derivative test. Take the derivative of f prime of x to get the second derivative f double prime of x, which is 6x minus 12. Now, plug your critical points into the second derivative. For x equals 1, f double prime of 1 is 6 minus 12, which equals negative 6. Since it's negative, the function is concave down, and x equals 1 is a local maximum. For x equals 3, f double prime of 3 is 18 minus 12, which equals positive 6. Since it's positive, the function is concave up, and x equals 3 is a local minimum. A common mistake is plugging the critical point back into the original function or the first derivative for the test. Always use the second derivative to determine concavity. A great mnemonic to remember this is, if the second derivative is positive, the function is happy or concave up, so it's a minimum. If the second derivative is negative, the function is sad or concave down, so it's a maximum. Next up is L'Hopital's rule, which is a lifesaver for limits that result in indeterminate forms like 0 over 0 or infinity over infinity. A classic FE exam problem is finding the limit of sine of x over x as x approaches 0. Direct substitution gives 0 over 0, an indeterminate form. L'Hopital's rule says we can take the derivative of the numerator and the derivative of the denominator separately and then evaluate the limit. The derivative of sine of x is cosine of x. The derivative of x is 1. So we evaluate the limit of cosine of x over 1 as x approaches 0, which is cosine of 0 over 1, giving us a final answer of 1. The biggest exam trap here is using the quotient rule. Do not do it. Differentiate the top and bottom independently. Also, make sure the limit is actually an indeterminate form before you apply the rule. Otherwise, you'll get the wrong answer. Finally, let's discuss partial derivatives. These are used for functions with multiple variables. When you take a partial derivative with respect to one variable, you treat all other variables as constants. For instance, consider the function f of x y equals 3x squared times y cubed plus 2y. To find the partial derivative with respect to x, we treat y as a constant. The derivative of 3x squared y cubed with respect to x is 6x times y cubed. The derivative of 2y with respect to x is 0, since y is treated as a constant. So the partial derivative with respect to x is just 6xy cubed. Conversely, for the partial derivative with respect to y, we treat x as a constant. The derivative of 3x squared y cubed is 9x squared y squared, and the derivative of 2y is 2. The exam tests this by simply asking you to compute one of the partial derivatives for a given multivariable function. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.